Welcome to this explainer. I am so thrilled you're joining us today. Look, we are going to dive right in because we have a really fascinating shift in perspective to talk about, drawing from some great insights over at the Captcha AI blog. We're looking at building a PHP Composer package, but through a very specific lens. You see, a PHP Composer package is absolutely not just reusable code. Once multiple apps start depending on it, it basically becomes the ultimate reliability layer for how your entire team handles API failures, timeouts, exceptions, and upgrades. Honestly, it's the defining difference between smooth scaling and total system chaos.
You know, there's this real illusion of simplicity when you're first building an integration. We've all been there, right? A PHP team usually starts small. One application just needs to call an external API. So a developer writes a basic raw curl request. They submit the parameters, they pull for a result, decode the JSON, handle a few obvious errors, and return a value. The feature works. The job runs. The team moves on. Boom, done. It feels like a total success. But watch what happens next.
The integration spreads. It's literally like a virus. Suddenly, a Laravel job needs that exact same API. A background worker just copies and pastes the polling logic. An internal dashboard checks API balances in one place, but totally ignores them in another. One project uses a super short timeout while another waits way too long. One workflow treats every single failure as retriable, while another just crashes completely on errors that easily could have recovered. Eventually, nobody, and I mean nobody, knows which version of the API logic is actually the correct one. It's absolute chaos.
So let's just hit pause for a second. The question you should be asking isn't simply, can my team call the API? Honestly, any developer can do that. The better, much starker question we need to ask is, can the team operate this API dependency predictably across PHP projects? This is the exact moment a Composer package stops being a simple developer convenience and becomes something much, much more important.
And that brings us to a massive paradigm shift. The Composer package operations layer, a PHP package for an external API, like Captcha AI for instance, isn't just some neat way to write your code or call methods. In production, it centrally defines how your entire team handles HTTP transport, timeout behaviors, polling, fatal errors, balance checks, package versioning, and upgrade safety. So, how do we actually build this? Let's open up a practical checklist.
Here is our playbook, kicking off with the first 3 steps. Step 1, define the package's operational role. Ask yourself, is this for one app, multiple Laravel services, background jobs, internal tools, or is this for public distribution? The wider the usage, the stronger your documentation, configuration, and versioning need to be. Step 2, centralize your request and polling logic. Seriously, stop repeating raw curl calls across projects. Put the submission, polling, JSON parsing, and timeout handling into one shared package to keep everything consistent. And step 3, use clear exception classes. Do not treat every failure as the exact same problem. Let's look at exactly why that matters so much.
Honestly, this is why step 3 is a total game changer. Think about it. If your code just throws a generic error, debugging in a live production environment is practically impossible. You have to separate submit failures, solve failures, timeout failures, network issues, and fatal account errors. A submit exception for an invalid API key, that means you check the dashboard. Frequent timeout exceptions, that means you need to increase your wait time. A guzzle connection error points straight to your network or firewall. Clear exceptions help your operations team decide immediately whether to retry, alert, fail fast, or investigate. It saves so much headache.
All right, moving on to the next operational chunk. Step 4, make timeout and polling highly configurable. Different workflows demand totally different limits. A scheduled background job might tolerate a long wait, right? But a user-facing web flow needs to fail fast. A queue worker may need really strict timing. Defaults are great, but production systems absolutely need control. Step 5, use a production-ready HTTP layer. And step 6, include balance visibility and checks. Checking your API balance isn't just some billing detail. It actively prevents avoidable workflow interruptions before massive high-volume jobs run.
Now, zooming in on that HTTP layer for a second, you might be wondering, why go with Guzzle instead of just using native curl? Well, native curl kind of leaves you hanging with raw calls and manual JSON handling. Guzzle, on the other hand, gives you PS7 message interfaces, automatic JSON handling, connection pooling, and middleware support out of the box. For broader PHP compatibility, sure, consider PSR-compatible patterns. But using a structured HTTP client model is just the practical, robust choice for integrating external APIs.
Okay, let's round out the last 4 steps of our playbook. Step 7, plan your framework integration incredibly cleanly. Step 8, define governance. How is this package actually being shared? Step 9,
Add specific observability hooks so you aren't just flying blind in production. And finally, step 10, assign clear package ownership. Let's break a few of these down a bit further.
Digging into step 7 specifically for Laravel, the guidance from the CAPTCHA AI source is super clear here. Please, do not scatter your setup code everywhere. Instead, register the client as a singleton in a service provider. Bind that client with the API key pulled securely from configuration. And then, just inject it via constructor injection in your jobs, commands, controllers, or services. This keeps your configuration pristine and so much easier to maintain across multiple microservices.
Then there's step 8, governance. You have to decide where this package is actually going to live. If it's strictly for internal use, you can just reference it via a Git repository directly in your composer.json file. But if it's for public distribution, you really should publish it directly to Packagist. Either way, though, the requirements are exactly the same. You must have strict versioning rules, release notes, and really robust README examples. This governance exists for one core reason: safety. It lets downstream projects upgrade securely without accidentally breaking production.
And speaking of keeping things safe, step 9 is all about observability. A package that silently fails or just spits back a generic value, that gives you zero production signal. Absolutely none. You need to expose metrics. What method was executed? What was the total duration, the task ID, the specific exception type, the error code returned, the timeout status, the final result status. Teams need to see request volumes, success rates, response times, and exception types if they're going to truly operate the system.
So, we've got the blueprint of what to do. Let's flip it and talk about what not to do, the common anti-patterns. Number 1, copying raw curl logic into every single PHP app. Just stop doing that. Number 2, relying on generic exceptions for every failure, which, as we discussed, makes debugging totally impossible. Number 3, hard-coding your timeout and polling values, which steals control from the apps that desperately need it. And number 4, skipping balance checks right before kicking off high-volume jobs, which just leads to massive, painful mid-process failures.
Continuing that list, mistake number 5, hiding your HTTP transport behaviors so much that developers literally can't configure their own connections. Mistake number 6, misconfiguring Laravel by scattering API keys all over the codebase. Mistake number 7, publishing or sharing a package without documentation, versioning, or clear ownership. Who maintains it, right? And mistake number 8, building automated CAPTCHA workflows without actually reviewing the platform permissions and rules. Listen, these aren't just minor coding errors, they are critical system vulnerabilities caused directly by a lack of governance. Which really brings us to the final thought I want to leave you with today. I highly encourage you to take a hard look at your own code bases. Ask yourself, is your shared PHP package a true operations layer that gives you predictability, visibility, and control? Or is it just shared infrastructure without a clear operator, basically just waiting to cause chaos at scale? It's a vital question for any focused learner looking to level up their architecture. Thank you so much for joining me in this explainer. Now go audit those integrations.